it is necessary to account for carbon soil changes under different land-use categories. So, considering the size of this carbon pool, measuring the soil organic carbon change is quite challenging due to the high spatial variability of soil organic carbon and slow process of carbon accumulation or loss from the soil. In other words, the change in soil organic carbon in time is smaller depending on the change with, considering the size of the pool. So, in order to detect some relevant changes in soil organic carbon, a high required density of high sampling density is required. This poses a quite noteworthy cost challenge, and this is the reason why only the minority of countries has done several national soil inventories. It's also the case with Croatia, so we have one national soil inventory which is used for our national inventory reports, and the second one is still lacking. In the lack of these repeated national soil inventories, another possibility to estimate soil organic carbon change is to use the alternative and cost-effective method, which is the modeling approach. So this research aimed to investigate is the process-based model, BAM-BGC-MUSO, which is currently the only operational model in Croatia for modeling forest ecosystems, applicable for estimating soil organic carbon change in soil organic carbon pool. For this, we perform soil organic carbon modeling using the already mentioned model BAM-BGC-MUSO. It is the biogeochemical model with multi-layer soil module. It simulates storage and fluxes of water, carbon, and nitrogen in soil-plant atmosphere system. So it contains several processes, multiple processes like photosynthesis, decomposition, chemical radiation, and a lot of more. So as the input files for this model to be run, it needs many variables and parameters, such as meteorological variables, plant ecophysiological parameters, soil and site characteristics and management. And it offers to its users more than 2,000 output variables. So in our case, we use the output variables, soil organic carbon. The model is usually has three phases, so it's speed-up, transient, and normal run. And this model version 6.2 has been calibrated for all forests in Croatia within my PhD thesis. So this calibrated model was used for this validation. So if you were yesterday present on this conference, Alessandro De Marco already pointed out the importance of having measured data to be used in the validation of different kinds of models. And in our case, we are using the data from Oak sequenced experiment. So this experiment was established in management unit Jasperska Lugovi in 2010, and it consists of several stands of different ages. In this study, we used 6 for a stand within this sequenced experiment. So in the permanent plots, these stands, on a yearly basis, above ground biomass is being measured, and in 5-year intervals, soil organic carbon and carbon stocks in forest floor are being measured. So soil organic carbon has been measured firstly in 2012, then in 2017, and the last measurement was in 2022. This enabled us to investigate what is the soil organic carbon change within this 10-year period, so from 2012 to 2022. So the comparison of measured and modeled soil organic carbon changes, that is the validation of the model, was performed at 2 levels. So the first level was to look at the period from 2012 to 2022, And the second level was to look at the rotation period of the forest. That actually was enabled because we had this experiment. So, for the beginning, in the period 2012 to 2022, the solar organic carbon was found to be stable, both in measured and modeled data. What we see here, here are this presents the mean of each forest stand within the Brown-Stiglitz experiment. So we have 6 points, that is 6 stands for each sampling year. The lack of trend in measured data would be attributed to the high spatial variability of solar organic carbon, which is seen here on this graph. Which is seen on the left graph. This is, although the both trends were not significant, what we see is that in measured data we have a negative sign, and in model data we have a positive sign. So this is something that needs to be investigated more. And what is really important here to note that considering that both trends were not significant, it is not possible, or we can say that to say if this model is applicable to estimate solar organic carbon is inconclusive. So the comparison still is in this case inconclusive. What we would need in the future is measured solar organic carbon data and trend that is positive and negative. And this would enable us to reliably estimate if the Baum-Ridge simulus can really reproduce solar organic carbon change. For this, it is important to continue the measurements in the Brown-Stiglitz experiment. So we need longer time series and also the higher sampling density to detect some change in the measured data. When looking at the rotation period, what we see here is the age of the stands, and here I'm presenting only the year 2012. So the squares are measured data, and the point is the model data. And what we see here is that if we are looking only at the year 2012, we don't have a significant trend neither in modeled and in measured data.